All right, you guys, I wanted to record a quick video about using dimensional analysis to solve problems. So right now I'm working on the document week 1, lesson 2, dimensional analysis notes. This is something we did in class. If you were absent, go ahead and use my slides to fill in all of these blanks and these blanks and these blanks, okay? All right, let's scoot down to some of the practice problems so we can work through it together. All right. Getting to this first one, it says convert 5.33 hours to seconds. Maybe as you read that, you're thinking, okay, hours, I could go from hours to minutes and minutes to seconds. You're doing exactly the process of dimensional analysis already in your head. The method that we're going to want to use in class is a method where we know how to write it out in a systematic way. That's because someday you're going to get to a problem where it's not as simple as going from hours to seconds, and you don't know exactly what to do to get from the start to the finish. Our method begins by recording our starting value. As mentioned in the notes, our starting value is always going to be a number that goes with a unit. So we have 5.33 hours as our starting value. The thing we want to get to is seconds. The ending, as mentioned in the notes, is always going to be just a unit. So seconds without a number. The number is what we're looking for, how many seconds. And then we use conversion factors to get from the start to the end. So we need to go from hours to seconds. So I'm thinking we can go from 1 hour, which is equal to 60 minutes. We can use that conversion factor. And then we need to go all the way to seconds. So we know 1 minute equals 60 seconds. I get a lot of questions about how do you know when you're done listing conversion factors. You know when you're done when you have one conversion factor that has a unit matching your starting value, one conversion factor with a unit matching your ending, and then your other 2 units are the same, those leftover ones, or your other 4 or whatever. They have ones that can cancel them out. Okay, so you need 2 of your other ones. All right, so how do we set up this problem? I'm going to zoom in a little bit here. So we start with our starting point. We're just going to put that out into space, 5.33 hours. We're imagining that this number is on the top, okay? We always start with a number on the top. Then we set up these cool bracket things that are so common in dimensional analysis. This is where we put a single conversion factor. And we want to organize that conversion factor so that we can cancel out the units that we started with, the hours. The way that we do that is we find our conversion factor that also has hours. So 1 hour equals 60 minutes. And we put the hours on the bottom. So 1 hour equals 60 minutes. I took this conversion factor and I just organized it in this way. When 2 things are equal, you can put them above and below each other like a fraction. I decided to put the hours on the bottom because when you have 1 unit on top somewhere in your dimensional analysis problem and 1 unit on bottom, you can cancel them out. Now I'm left with minutes, but I want to get all the way to seconds. So I need to do 1 more conversion factor, 1 more set of brackets, okay? Again, I want to cancel minutes, so I'm going to put my 1 minute from this conversion factor on the bottom. So it cancels this minute that's on the top. And then 1 minute is equal to 60 seconds. The final step is to solve this or to calculate it with a calculator, okay? You should pause right now and try to calculate this with a calculator. Remember that things on the top get multiplied, things on the bottom are divided. Okay, when calculating, I'm going to show you with my calculator on the right side of the screen. I should do 5.33 times 60 times 60. And I get 191.88 or 19,188. And that needs a unit. The only unit I had left over was seconds. So did I answer the original question? The original question was 5.33 hours to seconds. So there are 19,188 seconds in 5.33 hours. on my calculation, you guys, I did not divide by 1 or divide by 1. The reason for that is that dividing by 1 gives you the same answer you already have. So when you guys are calculating, you can ignore the ones in your dimensional analysis because multiplying and dividing by 1 gives you the same number. You can also leave them in there if it helps you. All right, let's do another one. I'm going to do 3.5 years to hours, number 3 here. So scroll down to number 3. Starting point, 3.5 years. I know that because it's a number and a unit. Ending point, hours. It's just a plain old unit. Conversion factors. Well, you're already thinking, I know how many days are in a year. 1 year equals 365 days. And I know that in 1 day, I can get to hours by saying 1 day equals 24 hours. Okay, now I have 1 unit in my starting units, or 1 conversion factor in my starting units, and I have 1 conversion factor in my ending units, and then my other ones will be able to cancel out because I have them in both places. All right, let's set it up then. Starting point goes off into space, 3.5 years. Set up my first conversion factor. I want to cancel out years, so I'm going to use this conversion factor, and I'm going to put the 1 year on the bottom because I want years to cancel out, and I'll put 365 days on top. Now my years cancel, and I'm left with days, but I need to go all the way to hours. So next I have to use my next conversion factor. I want days to cancel out, so I'm going to put the 1 day from this conversion factor on the bottom, and I'm going to put the 24 hours on the top. My days cancel out, and I'm left with the unit of hours, which is what I was trying to get to. So I'm good to go. Last step is to solve it. All right, multiply what's on top, divide what's on bottom. Pause and try solving it with your calculator on your own. Okay, let's calculate together. 3.5 times 365 times 24. Notice I didn't divide by my ones again. And that's okay because they're the number 1. All right, I got 30,660 or 30,660. Don't forget the unit. You work so hard to convert it into this unit. Make sure you write it down. Hours. Okay. All right, let's do one more together here. Number 5 is 5.9 feet to centimeters. Write in right now, pause and write in your starting point, your ending point, and the conversion factors that you're going to need. And for the conversion factors, you might need to reference this chart down here. Remember, you need at least 1 conversion factor with your starting units, 1 with your ending units, and then the other ones need to match up and be able to cancel each other out. Pause and try to write down the starting, the ending, and the conversion factors. Okay, the starting point is 5.9 feet because it's a number and a unit together. The ending point is centimeters. It's just a unit by itself. And we need to go from feet to centimeters. When I look down at the chart on the bottom, I see feet to meters. So I could go from feet to meters, and then I see from meters to centimeters over here. Or you might have noticed that I could go from feet to inches on my own using my own knowledge, and then from inches to centimeters, okay? Remember that if you were going to use this method, that 1 foot equals 12 inches. So that's another way that you could have done it. I'm going to use the ones in blue since those are both on our chart here, okay? So 100 centimeters equals 1 meter, and 3.3 feet equals 1 meter. Let's check to make sure that I have enough conversion factors. I have 1 that matches my starting. I have 1 that matches my ending, And then my other two match as well. So I'm good to go. Last step is just to set it up. Pause and try to set it up on your own. You need a starting value here, conversion factor, and then you should be good to go. Okay, I'm going to start with 5.9 feet. That's what we defined as our starting point. Now I need to cancel out feet, so I'm going to take my conversion factor that has feet in it, and I'm going to put the 3.3 feet on the bottom and the 1 meter on top. That way my feet cancel out. Now I'm in units of meters, but I need to go to centimeters, so I got to use my second conversion. I'm going to put the 1 meter on bottom so that I have a meter on top and a meter on bottom, and they can cancel. And then I'll put the 100 centimeters on top. The final step is just to solve. That means type it in on your calculator. Remember, anything on top is multiplied, anything on bottom is divided. So I'm going to do 5.9 times 100 divided by 3.3. And I get 178.8. And I need a unit with it. I ended in centimeters, so my final unit is centimeters. If you have any questions, you should send me an email or a Schoology message. I would love to clarify some things. You should go back and try question number 6 and question number 4 and question number 2 on your own. Question number 4 is a challenging one, okay? You might need to use 3, 4, or even 5 conversion factors to get from the start to the end. Good luck. You got it. Let me know if you have questions.